All right, now we are in business. So this is our last session on trigonometric functions and our introduction, where we're going to start with problem 15.5. We have these two side lengths and one angle that we don't know and we have to find. Well, the angle is the simplest one, right? Because, so let's say this is the first thing I'm doing, and you don't have to do this first, but this is the first one I am thinking of. 30 degrees plus my angle theta plus the 90-degree angle must equal 180 degrees, interior angles of a triangle. So if I put those two together, I want to do it nice. I want to do it nice and slowly. Have enough steps for people to have something to work from. So then I subtract the 120, excuse me, from both sides, and I get theta is 60, which of course you might have already known because of my knowledge of the 30-degree, 60-degree triangle, maybe. But you do want to show some work and make it clear why you get 60 there, just in case something else goes wrong. So now I like to use the angle that was given, just in case I'm making a calculation mistake and I don't notice it or something. So I'll use 30 with its opposite side and adjacent side, maybe next, right? I have to now pair the 30 degrees and the one length side to C and to B, two separate situations. So let's do B first. So I know that the tan of 30 degrees will be opposite over adjacent. So that then immediately tells me B is tan of 30 degrees. I can go to my calculator, see if it's awake. Let's say 2 plus 3. 2 plus 3 is 5. Good job, MathBot. And ask it, tan function in degrees, 30 degrees. So for me, that is tan D, so that it sees 30 degrees. And it says some decimal number. That, of course, for a final answer, I have to round 0.5774 if I round it. But that's rounded, right? I do have it. I don't want to use a rounded number in a future calculation, but luckily I don't really have to. You have two choices to find C. I prefer to use as many of the existing information, the original information, as I can. So I'll do a similar thing with the 30 degrees and the one side length and C. But I do have options that I'll mention in a second. So now this is adjacent and hypotenuse, so that's cosine 1 over C. So that means, now many ways you could do this. You could see it as a ratio equation here. You can multiply both sides by C and divide by cosine 30. Regardless, you get C equal to 1 over cosine 30 degrees. And let's calculate that. So now it is 1 over cosine in degrees 30, like that. It does not, I don't care what other weird things it shows in its calculation to shortcut this. Let's just pretend it looks it up, right? But it actually does much fancier things. That is okay. We don't need to care about that. I care about the decimal number, 1.0014 if I round it. Rounded, of course, and I do have them all. I could have gone here and used Pythagoras because I have two of the three side lengths, and I can say 1 squared plus b squared equals c squared. and then find C, and it would be the same. Just be careful, don't use a rounded number for a future calculation. So when I use B in this calculation, I have to use all the decimals, or as accurately as I can. Or even in place of B, I'll type tan 30. So just be aware of that, and to avoid that hassle of being aware of rounding errors, going further into other calculations, I try and use as many of the original given information as I can. So that gives you a start for that problem. You have some others to practice. Try it out. See which one do you want to start first. There isn't a set order in this kind of question. All right. So oopsie, zoom in more. Come on, zoom. There we go. The last thing we want to do, as I just check if everything is recording and looking decent. Oh, it looks okay. So far, so good. Is the last thing. Drag my book back here. Look at some word problems to see where do these trigonometric functions maybe come up. Now, of course, we're going to see a very simple introduction, but I hope after that it's not difficult to see that even in more complicated situations, these trigonometric functions are just going to have a bigger and bigger role. And really, whenever I have to measure something where an angle is in play, it really can't be done without trigonometric functions efficiently. Let's look at exercise 15.5. From a cliff, your line of sight makes a 30-degree angle with the horizontal. You see a boat 300 meters away from you. How close is the boat from the cliff? Now, in these questions, a sketch is a very handy strategy to just give myself time to check if I understand the question, if I have all the information. So let's suppose here is my cliff. There is the water. There I am. Now I'm going to ignore my height because they don't say anything. Unless they say something, I ignore it. So I'm laying down right on the cliff edge. A little scary, but hey. There is a little boat. Little boat. Whee. There we go. And I am measuring from the horizontal, a line to the boat, like so. So then, of course, I have a vertical line and a line along the water, and there is my triangle, a right angle triangle. Now let's see what they give me. It says that the line of sight, that's this hypotenuse side, makes a 30-degree angle with the horizontal. So that is 30 degrees. Also called the angle of depression. You're measuring it from a horizontal line wherever the viewer, the observer is. You see a boat 300 meters away, so that's 300 meters. How close is the boat from the cliff? So that's what I want to know. Okay, so now that I've set it up, just like any word problem, I need to make sure that I can understand what is happening here. First step in a word problem is to explain what your unknowns mean. Pick a symbol. Let's pick question mark in a box. It can be anything. It can be a letter, it could be a symbol, it could be a smiley face, because you love trigonometry so much. Either way, I want to say what that represents. So let question mark in a box represent the distance to the cliff, which I assume is perfectly vertical. And I can even say as shown on my diagram. My diagram can help explain the situation and what I'm going to do, but it's not something that can stand on its own. You need words, you need sentences, you need an explanation. But I can definitely point the reader to my diagram. That's okay. So what do I have here? So I need another angle here, right? But I know the horizontal with the vertical makes 90 degrees. So the angle inside my triangle at the top here is 60 degrees. I need an angle that's not the 90-degree angle. Okay, 60 degrees. Now, yes, the other one is 30 degrees, but let's just practice. I have to be able to use either angle. I have a 60-degree angle there. Let's use that one. So then, based on this 60-degree angle, the interior angle, I have an opposite edge and the hypotenuse. So that means I'm going to use the sine function, sine of 60 degrees. It equals opposite, and its length is represented by question mark in a box, over hypotenuse. Again, if you pick the other angle, it'll be different because the sides will be relative to that angle. But that's the one I picked, so I use a sine function. So that's my equation that describes the relationship between the quantities that are involved. So question mark in a box is solved simply by multiplying both sides by 300. 300 times sine of 60 degrees. And in this case, because the sine function isn't in a complicated calculation setting, which it won't be for us, we're perfectly fine to just have the input. There's no other input here. There's nothing complicated as input for the trigonometric function. Degrees is okay to stick with the unit that the question gave me. So question mark in a box is something the calculator can tell me. Let's do it. 300 times my sine function's input is degrees, so I in MathBot have sine d, and it is 259.81. Let's round to 2 decimal places this time. Whatever the question says, if the question doesn't say anything, check the instructions in front of your test. If that doesn't say anything, then do whatever you want. And then a concluding sentence is always nice. Question mark in a box is exactly what I wanted to find. So that would be done. The boat is approximately 259.81 meters from the cliff. Of course, we can always make this more complicated. That's not the point here. The point is to illustrate the use and practicality of these trigonometric functions, because they give me a way to link side lengths and angles together in a right angle triangle. Essentially, that is what they do. So I have information about the angles. I have information about some lengths, some distances. The link between them is a trigonometric function by way of these ratios and angles. Okay, so those are nice. Fairly manageable in complexity, but still some practicality to them. We have a couple more, and that's all we have to do for today. It's not a long day, but it is an important day to wrap things up in a satisfying way to see where do these trigonometric functions come up at all. Exercise 15.7. Again, I just read it once, and then we'll go through it and explain it by way of a diagram. When you lie on the ground and look up at the light of a lamppost, the angle of elevation is 60 degrees. If your eyes are 2 meters from the base of the lamppost, how high is the lamppost? Let's see. So you're standing pretty close. Fair enough. You can stand wherever you want. Exercise 15.7. Again, I want to draw a diagram here to see what is happening. So I have the ground. I have a lamppost. It has a light. I am laying on the ground so that my height does not play a role. I'll make it a little bit further just so I have some space to write stuff. That's me looking up at the lamppost. So I'm going to look up at the lamppost. Oopsie, it's close enough. And the angle of elevation, my line of sight makes an angle with the horizontal. We call it the angle of elevation, 60 degrees. 90-degree triangle. My eyes are 2 meters from the base. How high is the lamppost? I'm going to call that question mark in a box. So with the diagram, it's given me time to think what the question is telling me, what the question is asking, make a plan for how I will approach this. But I have to start by saying the unknown and the symbol that I choose, they mean this. Let question mark in a box represent the height of the lamp post. Is lamppost one word or two? Apparently two. Okay. I do math, I don't do English. Lamppost. So now I can even say here, as shown. But you have to have a sentence. The reader doesn't know. Was this just a little doodle? Or should I be looking at the picture? Oh, I should. Okay, now I'll look. Now I have to relate the quantities given and the symbol relative to the angle here, 60 degrees again. I have an adjacent edge and an opposite. So that will be the tan function. Opposite over adjacent. From that equation, I now look, okay, what do I have to do to solve question mark in a box? I have to multiply both sides by 2. So question mark in a box is 2 times tan of 60 degrees. Question mark in a box is something the calculator can tell me. But there's a stepwise procedure to this that leads me to the answer. I don't care what the answer is originally. Now I have a calculation. 2 times tan is again in degrees here. So 60 and we get a final answer 3.46. Let's say 2 decimal places. Concluding sentence. The lamp post is approximately 3.46 meters tall or high or whatever. All right. So even in this somewhat simple case, I want to focus on the steps involved in a word problem. Because I see in elementary school kids, actually all kids, because they don't have the experience the patience that you develop over time. They read this, they read a question like this, or whatever the question is, a word problem, and they want to know the answer right away, and conclude that if they don't know the answer right away, well, there's something wrong with them. They're stupid, or their brain doesn't do math, or whatever conclusions they make that are absolutely ridiculous. When in fact, we don't know the answer until the very end. And I also don't give the answer any attention. I set up and check my understanding of the problem by way of a diagram, by way of defining any symbols that I'm going to use. Then I simply come up with an equation that relates these quantities. And because there are angles in a right angle triangle and side lengths of that triangle, I have trigonometric functions involved. But this is just an equation, a mathematical sentence to explain how these things are related to each other. I still don't care about the answer. I then look at this equation regardless of where it came from. How do I solve for this unknown following the rules within this mathematical language? I then do it. And then I find an answer. So my steps lead me to the answer. I never obsess about the answer. The answer is a natural result of my process. It comes out automatically. The equation, the process will lead me there, and I never have to worry about it. Okay. Let us do one more, which I think is related to the previous one, but we'll have to read it. Let us read it. Exercise 15.8. You're now standing up, and your eyes are exactly 1.7 meters above the ground. When you look up at the light of a lamppost, the angle of elevation is 42 degrees. It might be a different lamppost. If your eyes are 2 meters from the base of the lamppost, how high is the lamppost? So similar, we're just making it maybe a little bit more realistic. But it's a new question. What was this? 15.7? You know, I just opened it and I don't remember. No, 15.8. Exercise 15.8. New question, new diagram. There's my ground. There is my lamppost. There is the light of the lamppost. It is shining. I am standing, let's say, over here. I am looking at the light. It's making an angle. Oof, that is not horizontal. I apologize. That is not horizontal either. You know, it's close. It's not good. I'm sorry. I'm going to spend our remaining minutes just trying to draw a horizontal line. Can I not do it? I need a different tool here. It was obviously the tool was not me. That makes a, what did we say? 42-degree angle with the horizontal. Angle of elevation. My line of sight to the horizontal. And of course, the horizontal line, vertical line, 90-degree triangle. And this height is 1.7 meters. This height is again 2 meters. And there we go. So now our triangle is a little bit raised up. But that's okay. I want to know the same thing, but I don't have to do it in one go. I can now define question mark in a box as just this distance that I don't know, raised up by 1.7 meters. So I have to redefine my question mark in a box. That's totally fine. Let that represent the, let's say, the height of the lamp post past 1.7 meters as shown. I want to make sure that my sentence here is as clear as I can make it. I can't say it's the height of the lamppost because it's not, because in my triangle it's only the side length that's used. And that side length might not match exactly what the question wants, as in this case, because the triangle is sort of raised up. So I want to be careful that I explain myself correctly. But still, looking at the triangle, I have an opposite edge and an adjacent edge. So I'm going to go tan again, tan of 42, opposite over adjacent. So then the question mark in a box is 2 times tan of 42 degrees, which is, calculator will tell me, 2 times tan in degrees 42 and I get 1.80. Very close, but still rounded, so be aware of that. Now in this case, that's not my final answer. The lamp post is this answer, 1.80 rounded, plus the 1.7 that it was raised up, right? So let's say here approximately, because that helps the reader be aware that I understand that this is a rounded number. Let's see over there. So 1.8 plus 1.7, 3.50 approximately meters tall. Still rounded. Looks nice and clean, but there were some decimals, right? Some 8s and 0s lingering after this one, but that's okay. So again, we're not going to be super complicated. That's not our goal. Our goal is to see where trigonometric functions could come in a more practical sense. And this, I think, achieves that goal without being too intimidating. But there's still a procedure that's always there in a word problem. Set it up. Define unknown lengths or quantities. Draw a picture. It's always nice. Write an equation that describes the situation and a relationship between the given quantities, the quantities that I'm interested in. Solve that equation, whatever that requires. It's independent of the practical aspect. And then just wrap it up with a nice concluding sentence to make it clear that I understand that the actual answer to this question is 3.5, not the 1.8 that my equation gives me. Those aren't necessarily the same thing. What the question wants and what I did mathematically aren't perfectly the same always. I'm trying to answer the question in the end. So these three hopefully set you in the right direction. You'll see that we discussed the first problems already. You'll see that there are a few word problems. I tried to make some a little bit more interesting. If you don't like 15.8, it's too much for you. That's okay, just leave it until the end. Build up to it. But if you don't like it, I totally understand. Our goal is ultimately to just get an introduction. So I did make this one a little bit more interesting and involved on purpose. If you like the challenge, go for it. If you don't, it is a little bit beyond what we're trying to aim for. But don't just shy away from it. Just build up to it. It's definitely something you should be able to do. Just don't do it if you're not ready for it. Build up to it. Think about it when you've done everything else. See, there's a lot of other questions. You've done everything else. Then you come back to 15.8, and maybe you're more ready. Slow and steady, one step at a time. Build it up, and it becomes far less intimidating. All right, are there any questions on trigonometry?